Hey guys, welcome to the channel, and in this video I will be explaining you one question on tree, that is to invert the binary tree. So first I will show you with the example how to invert the binary tree and what the inversion means, and after that I will show you how to code this. Suppose if we have given this binary tree, the inversion of binary tree means, let's say if we have this nodes 1 2 3, and if someone says that invert this binary tree, then the inversion will look like this. That means the right child will become the left child and the left child will become the right child for all the nodes present in this particular tree. So this is basically simple inversion of an binary tree. So what we need to do, we need to invert this given binary tree which we have given to us. Okay, so what we are calling, suppose if we are calling this invert binary tree function using the pointer a. Okay, so let's say this is the root and its pointer is a. So we are calling invert binary tree function from main with the argument as this particular pointer a, which represents the root. So what we are going to do, as we know that when the inversion is done, the right pointer is pointed by the left child and the left will point the right child. Okay, so inversion will happen. So for that case, what we are going to do, we are going to take two struct node pointer, that is node star left and node star right. Okay, and we call this we call the invert binary tree function again for this particular variable L on the right side. That means we are calling invert binary tree function on node number C for this particular variable L, which represent the left side, because at the end this will be the left child of this particular current root. So we are calling invert binary tree on C for this particular variable L, and we are calling invert binary tree on B for this particular right child. Okay, so this will done for this particular node 1, and once it is done it will be moved to this particular node 2. For node number 2, what we have we have let's say let me draw it here. This is the node number 2 and the locations are B and D. Okay, so when we call invert binary tree on this, invert binary tree will be called on B to right for this variable L, and for the variable R we call invert binary tree on B to left, because the left child will become the right child of this current node 2 after all the iterations, and the right child will become the left child. Once we process this left child, let's say D, we found out that the left and right value for this particular node is null. So this is the leaf node. So in case of leaf node, we are simply returning that value only. Okay, so what we are here for this R child, we have the node value pointed by 4, and for the left child we have null, because we are calling the right child for this particular variable L and its right child is null only, so we are returning null from here. So what we got at the end, we got that for this node number with value 2, the left child will be null and the right child will be 4. So as you can see, I have used the simple this subtree which I have used, and in this case inversion is done and it looks like this, that 4 will be the right child after the inversion and null will be the left child. Okay, so this is the case for this particular subgraph. After that, when we are in node number 3, the L is pointing to invert binary tree the current, that is C to right. Okay, and for variable R we are calling invert binary tree function on C to left. Okay, so when we are here at 6 is the leaf node, so we are simply returning from here. Okay, therefore the R will contain the node pointing by the value 6 and L will contain the node 7. Okay, so when we replace this will have 3 and the left child will be 7 and the right child will be 6. So as you can see, this inversion is also done. So the left inversion look like this for the node number 1, and the right inversion looks like this. Okay, but as we know that variable or the struct node variable L which we have take, it calls the function on this particular right node. Okay, so this right node will be now let's say this L will be pointing by this particular right node. Okay, and R will be pointing to this particular subgraph. Because we have called the invert binary tree on the right node for the L variable and invert binary tree for the left node in this particular variable R. So we have L pointing to this particular location 3 and R pointing to this particular location 2. So at the end, what we have at node number 1, we have for L we have 3, 7 and 6, and for right we have 2, 4 and null. So as you can see, the inversion is taken place here. So 1 will be the root, 3 and 2 will be exchanged, 7 and 6 will also be exchanged, and 4 and null is also exchanged. So inversion will be take place. So this is little bit tricky to understand using this example. So if it is not still clear to you, then I will show you how to code this, so that will be more clear to you. So here I have taken the same tree which I have showed you in the example. Let's see the function of the invert binary tree. So invert binary tree function, we have passed the root variable, that is this node number 1 in this example. Okay, and we check that if root is null or not. If root is null, then we are simply returning null from here. So this is a condition checking for null, and this is a condition checking for leaf node. If that is the leaf node, and we are simply returning that node only, that pointer to that node only, because we have nothing to explore on the left and right child of the leaf node. And we call invert binary tree function again and store the pointer which we got in this L variable, and we call invert binary tree function on right and store that into the R variable. Okay, after that, what we are going to simply do is we point root to left to the R variable and root to right to the L variable, because whatever we are currently at, let's say this root, and the left pointer is now pointing, let's say this is the left pointer, this is pointing to the right child, and the right pointer is pointing to the left child. Therefore the inversion will take place. So this is that condition only. So at the end, whatever is the result we got in L and R variable, that will be exchanged. That means root to left will be now pointing to R and root to right will be pointing to L, and at the end we are simply returning that root. Okay, so let's try to run this code, compile this code. It compiled successfully, and when we run it, it gives the traversal of this. That means if we have the graph, let's say we are generating the graph from here, we have 1, then we have the left point as 2, right point as 3, left is 4, right is 6, the right is 7. So this is the graph which we have took. So let me use the extra things. So these are not the values which we have to. So if we compile this again, we found out that the in order traversal for this graph which we have showed in the example is 4, 2, 1, 6, 7, 3, 4, 2, 1, 6, 6, 3, 7, not 6, 7, 3, 6, 3, 7. And when we invert this tree, it looks like this. Okay, so the in order traversal will be 7, 3, 6, 1, 2, 4. 7, 3, 6, 1, 2, 4. So it's showing the same only. So hope you got this question. This is little bit tricky to understand, but once you watch this video 2 to 3 times, it will be very clear to you. So if you find any difficulty, just feel free to comment. Okay, thank you.